Hi, in Lab 2 we'll be looking at charged tapes as lines of charge. The purpose of this lab is to improve our knowledge on the interaction of charged objects and use a more accurate model to improve our estimation of the electric charge of an object. To start, we'll go over our findings in Lab 1 and then the fundamental principles and assumptions we need to make the models. Then we'll go over the calculations and code made to improve our estimation of charge and also the visual models. Finally, we'll discuss and evaluate the results we obtained using the line model, where we found the positively charged tape had a charge of 2.947 times 10 to the negative 8 coulombs. In Lab 1, we estimated the charge of the tape by treating each piece as a point charge. In this lab, we'll try to estimate the charge again, but by modeling each piece as a line of infinitely small sections, each with a point charge. This experiment has the same procedure as the first lab, where we first created a piece of charged tape by ripping off a piece off of base tape. Then we test if the charge is positive or negative by rubbing a plastic pen and observing the attractive or repulsive interaction. Then, with two more pieces of charged tape, we lift a piece below the other until the top piece is floating and measure the distance. The law of attraction tells us opposite charges attract while like charges repel. This is how we know that the tape was positively charged when it was attracted to a negatively charged pen. Then Newton's third law tells us that every action has an equal and opposite reaction. This means that the top and bottom tape exert equal and opposite forces on each other. Newton's second law then tells us that a system in equilibrium has a net sum of forces equal to zero. We can therefore assume the only two forces that are acting on the top piece of the tape are gravitational and electrical forces, and that these forces sum to zero. We can then use Coulomb's law to compute the charge of an object by finding the electric force of an object and also using the relationship that electric force is equal to the electric field times the charge of an object. Finally, we know that our calculation will be more accurate if we include more sections of charges using calculus where a limit approaches infinity. To make the models for this lab, we assume that each U-tape had the same amount of charge, that the charges were uniform, and that forces due to air resistance were negligible. To go over some data, the length of the tape was 0.22 meters, the mass of the tape was 0.00022 kilograms, the distance between the tapes was 0.027 meters, and we know from Newton's second law that the magnitudes of the electric and gravitational forces will equal each other. So we use this in Lab 1 to find the estimated charge on each piece of the tape, as you can see, to be 1.322 times 10 to the negative 8 coulombs. To make the computational model using GlowScript, we inputted the data values into the starter code using the charge found from Lab 1. This section of code iterates through every piece of charge, in this case with 10 pieces, to calculate the electric force on the top tape due to the bottom tape, and to create smaller force arrows for each piece. You can see the code in more detail through the link in the description box below. In this computational model, the white arrow is the total electric force, while the little green arrows are the electric forces of each sectional piece. The yellow arrow represents gravitational force. The red represents the top tape, while the blue represents the bottom. As you can see, when we use the point charge found in Lab 1 on a model with line charges, the magnitude of the electric force is about 5 times smaller than that of gravitational force, which is clearly not balanced. In order to balance these forces, we use trial and error to estimate the magnitude of charge to be 2.947 times 10 to the negative 8 coulombs. As you can see, the magnitudes of electric and gravitational forces in this model are nearly equal. To conclude, if we were to compare the charge value obtained by Lab 1 by modeling the tapes as single point charges and the value obtained by the more accurate model using line charges, the charge obtained from the line charge model is around 123% larger. Then, to explain this difference between the charges obtained from the line charge model and the point charge model, the line charge model is more accurate because on the actual tape the charges are distributed. Thank you for watching.